Have you ever wondered how stars, those dazzling points of light in the night sky, come into existence? What fuels their brilliance and what becomes of them when their time runs out? The life of a star is a mesmerizing journey through creation, destruction, and rebirth. From their celestial cradles to dramatic final acts, stars play a crucial role in shaping the universe. Join us as we unravel the fascinating life cycle of stars, from their birth to their cosmic legacy, in this journey of awe and wonder. Nebula, the birthplace of stars. The journey of a star begins in a nebula, a vast cloud of gas and dust that serves as the cradle of star formation. Spanning light years, these dynamic regions are full of movement and energy, where gravity gathers raw materials to create the points of light we see in the night sky. Nebulae vary in type and behavior, with each offering unique characteristics. Emission nebulae glow vividly, often in red or pink as their gases are ionized by nearby young stars. Reflection nebulae appear faintly blue, scattering starlight like a cosmic mirror. Dark nebulae, in contrast, block starlight, creating shadowy voids that intrigue astronomers. Iconic examples like the Eagle Nebula's pillars of creation showcase the beauty and complexity of these stellar nurseries. Gravity is the driving force behind star formation, gradually condensing regions of the nebula over millions of years. As particles draw closer together, they form dense clumps called protostellar cores, where gravitational energy converts into heat. These cores begin to radiate faint light, marking the initial stages of a star's development. Not all regions within a nebula will form stars. Some lack the necessary mass to trigger nuclear fusion. However, those that succeed undergo a spectacular transformation, growing hotter and denser until fusion ignites. Once this process begins, a star is born, leaving its nebula behind. The nebula, though left behind, often continues to influence its surroundings, enriching the cosmos with elements for future stars and planets. Every star in the night sky reminds us of its humble beginnings within these breathtaking cosmic nurseries. Protostar, the star Awakens. The journey from a nebula to a star continues with the formation of a protostar, a dynamic and transformative stage in a star's life cycle. A protostar is a nascent celestial body still gathering mass and energy, striving to ignite the fusion reactions that will define its stellar existence. Though not yet a fully formed star, the protostar glows faintly from the gravitational energy of its collapsing core. This phase begins when regions within a nebula become dense enough for gravity to pull surrounding gas and dust inward, forming a spinning disk of material around the developing protostar. The rotation of this material results from the conservation of angular momentum, causing the collapsing matter to spin faster and transform dramatically. As gravitational forces compress the protostar's core, its temperature rises to millions of degrees, producing the faint but growing glow that signals its progress. Surrounding the protostar is the protoplanetary disk, a ring of leftover material that may eventually form planets, moons, and other celestial bodies. This stage is not just crucial for the star's birth, but also for the potential creation of planetary systems. The protostar's environment is turbulent, with magnetic fields and jets of energy interacting with the surrounding material. These jets can expel excess matter, clearing space and shaping the cosmic landscape. The pivotal moment comes when the core's temperature and pressure rise high enough to trigger nuclear fusion. Hydrogen atoms fuse into helium, releasing immense energy and stabilizing the star by balancing gravitational collapse with outward radiation pressure. At this point, the protostar transitions into a main sequence star, leaving behind its turbulent beginnings. The protostar phase is a fleeting yet crucial chapter, bridging the gap between the diffuse clouds of a nebula and the radiant brilliance of a star. Each protostar tells a story of resilience and transformation, a celestial tale inscribed in light, gravity, and the boundless creativity of the cosmos. Main sequence: the star's prime. Every star eventually reaches its prime, and this phase is known as the main sequence. During this stage, a star achieves a delicate balance between the outward pressure created by nuclear fusion and the inward pull of gravity. For many stars, this period is the longest and most stable phase of their lives, often lasting billions of years. The main sequence is where stars truly shine, both figuratively and literally, as they radiate energy and light into the vast expanse of the cosmos. The main sequence begins once a star's core temperature becomes hot enough to sustain nuclear fusion. This process primarily involves hydrogen atoms fusing into helium under extreme heat and pressure, releasing an immense amount of energy. This energy radiates outward, counteracting the force of gravity that constantly tries to collapse the star. The result is a star that maintains a stable size, temperature, and luminosity. The exact characteristics of a star during this phase depend on its initial mass. Massive stars burn through their fuel more quickly, shining brighter and hotter, while smaller stars like red dwarfs burn more slowly and steadily. For our Sun, the main sequence has been a time of relative calm and stability, lasting about 4.6 billion years so far. It is during this phase that a star provides the conditions necessary for planets to form and in some cases life to emerge. The energy emitted by main sequence stars drives weather systems, sustains ecosystems, and fuels the chemical reactions that shape planetary environments. The Sun's predictable and steady output of energy is a hallmark of its time on the main sequence, creating the perfect conditions for life to thrive on Earth. However, the main sequence is not an eternal state. As stars consume their hydrogen fuel, the composition of their cores begins to change. Over time, helium accumulates in the core while hydrogen-burning reactions shift to the outer layers. This gradual change in composition marks the beginning of the end of a star's main sequence phase. The exact duration and manner in which a star leaves the main sequence depends on its mass. Smaller stars may linger for trillions of years, while massive stars burn out in just a few million years. The main sequence phase is a star's golden age, a time when it achieves the stability and brilliance that define its character. It's the period during which stars contribute the most to their galaxies, providing light, heat, and the essential conditions for the birth and evolution of planets. For stars like our Sun, it's a reminder that even the most luminous and powerful entities in the universe experience a life cycle, moving from birth to maturity and eventually toward transformation. The main sequence is a celebration of energy, balance, and the sheer beauty of starlight in the cosmic arena. Red giant or supergiant, the expansion. When a star exhausts the hydrogen in its core, it undergoes a dramatic transformation, expanding into a red giant or supergiant. This phase marks the transition into its twilight years, where the star's size and brightness increase while its core experiences intense changes. Once stable, the star begins a journey of instability and grandeur, signaling the beginning of its eventual end. Depending on its mass, it will either become a red giant, like our Sun will someday, or a supergiant if it began life with significantly more mass. The transformation starts when hydrogen fusion ceases in the core, causing it to contract under gravity. This contraction raises the core's temperature and pressure, igniting hydrogen fusion in a shell around the core. The resulting outward pressure forces the star's outer layers to expand dramatically, cooling in the process and giving the star its reddish hue. A red giant can grow to hundreds of times its original size, while a supergiant can become thousands of times larger. For red giants, this phase often involves the fusion of helium in the core, creating heavier elements like carbon and oxygen. In supergiants, the process is more extreme, with layers of fusion producing elements up to iron. Red giants often create planetary nebulae, glowing shells of gas that surround the dying star. Supergiants, on the other hand, undergo more violent ejections, setting the stage for supernova explosions. The red giant or supergiant phase is a breathtaking chapter in cosmic evolution, showcasing the immense power of fusion and the impermanence of even the mightiest stars. These expanded stars are not only visual marvels but also key contributors to the chemical enrichment of galaxies. Their transformation is a testament to the universe's creativity and a reminder that even the most brilliant stars are finite, destined to evolve and pave the way for new generations of celestial wonders. Supernova or planetary nebula, the grand finale. The end of a star's life is a dramatic and breathtaking spectacle, culminating in either a supernova explosion or the delicate beauty of a planetary nebula. This grand finale is determined by the star's mass, marking its transition from a radiant celestial object to its final form. Stars with low to medium mass like our Sun end their lives more gently, creating planetary nebulae while massive stars erupt in supernova explosions, scattering the elements they forged into the cosmos. For stars like the Sun, the journey toward a planetary nebula begins as they shed their outer layers during the red giant phase. Over thousands of years, these layers are expelled into space, forming glowing shells of gas and dust illuminated by the hot, dense core left behind. These planetary nebulae, with their stunning shapes and colors, are some of the most mesmerizing sights in the night sky. The material they release carries elements like carbon and oxygen, enriching the interstellar medium and contributing to the formation of new stars and planets. Massive stars, on the other hand, take a far more explosive path, leading to a supernova. When the core of a massive star runs out of fuel, it collapses under gravity, releasing an immense amount of energy in an instant. This collapse triggers a shockwave that tears through the star's outer layers, creating a supernova so brilliant it can outshine an entire galaxy for a brief time. Supernovae are not just explosions, they are cosmic forges creating elements heavier than iron such as gold and uranium in their intense heat and pressure. The remnants of a supernova can form a neutron star, or if the original star was massive enough, collapse further into a black hole. These outcomes leave behind some of the most enigmatic objects in the universe, continuing to shape the cosmos in their unique ways. The grand finale of a star's life, whether as a planetary nebula or a supernova, is a reminder of the cosmic cycle of creation and destruction. From dazzling nebulae to the awe-inspiring power of supernovae, these endings are not just conclusions but the beginnings of something entirely new in the vast expanse of space. White dwarf neutron star, or black hole, the final form. When a star reaches the end of its life cycle, it transforms into one of three final states: a white dwarf, a neutron star, or a black hole. These outcomes represent the star's ultimate stage of evolution, and are determined by its initial mass, revealing the universe's incredible extremes and contributions of stellar remnants to the cosmos. Stars like our Sun, with relatively low to medium mass, end their lives as white dwarfs. After shedding their outer layers as planetary nebulae, their cores remain as dense, Earth-sized objects composed mostly of carbon and oxygen. Though fusion ceases, these remnants emit faint light from residual heat, cooling slowly over billions of years. Over time, white dwarfs may crystallize, forming a giant cosmic diamond. Massive stars, however, often end as neutron stars. When such a star undergoes a supernova, its core collapses under immense gravitational pressure, compressing into an object just a few miles across. Despite their small size, neutron stars can weigh up to 1.4 times the Sun's mass, and are composed almost entirely of tightly packed neutrons. Some neutron stars spin rapidly, emitting beams of radiation detectable as pulsars. For the most massive stars, the collapse of the core after a supernova can lead to the formation of a black hole, an object with gravity so intense that not even light can escape. Stellar black holes formed from stars at least 20 times the Sun's mass represent the ultimate extremes of space-time, where known physical laws break down. These objects shape galaxies and provide insight into the boundaries of physics. The final form of a star, whether a white dwarf, neutron star, or black hole, is a captivating chapter in its story. These remnants preserve the legacy of their parent stars, while enriching the dynamic and interconnected cosmos, highlighting the universe's boundless creativity and complexity. The cosmic legacy of stars. Stars are not merely celestial bodies lighting up the night sky. They are the architects of the universe, leaving a profound legacy that shapes everything we see around us. From the elements that compose our bodies to the vast structures of galaxies, stars influence the cosmos far beyond their lifetimes. The story of stars is deeply intertwined with the universe's history, making their legacy a cornerstone of cosmic evolution. At their core, stars act as cosmic forges, creating elements through nuclear fusion. In the intense heat and pressure of their cores, hydrogen fuses into helium, releasing immense energy. As stars age, this fusion forms heavier elements like carbon, oxygen, and even iron in massive stars. When stars end their lives in supernovae, they scatter these elements across space, seeding future stars, planets, and life itself. The remnants of stars also contribute to the cosmos, forming dense neutron stars, mysterious black holes, or expansive nebulae after their deaths. Nebulae in particular become stellar nurseries, where gas and dust from one generation of stars coalesce to form the next. This cycle of birth, life, and death underscores the dynamic nature of the universe. Perhaps the most remarkable aspect of a star's legacy is its role in enabling life. Without the elements forged in stars, planets like Earth could never have formed, and life as we know it would not exist. Stars are more than points of light, they are the universe's storytellers, shaping the past, present, and future. their influence continues to resonate across space and time, ensuring their story lives on. That wraps up our exploration of the life cycle of stars, from their stunning beginnings in nebulae to their grand legacies as cosmic creators. If you enjoyed this stellar journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the universe and reaching for the stars with us.